So the second part of this, I want to talk about constraints, and constraints really drive where and how your geometry interacts. It allows you to define it so you don't have it moving around on you, and basically it sets the relative position between parts in your assembly. So if we look at constraints, all right, and we can switch back and forth between this, which is super easy to see, and Inventor. So if we look here, all right, so a lot of you may not have thought of dimension being a constraint, but when you dimension something, you are constraining it. So if we go over here to Inventor and go ahead and open up a new part, and we'll extrude, we'll go to make a sketch. All right, a lot of people I saw in class or see in class, they'll lay down a box like this, and then they will dimension it. We'll say 0.25, and then once they dimension it, they'll say, oh wait, I'm still dimensioning. They'll say, I can move this, but Mr. D, I can't move this, I can't move this. When you have 0.25, the only place, the only condition that satisfies that being 0.25 away from the origin, from your x-axis, is that line. It can't move. It's constrained. It only can move the end parts. All right. So one handy thing, if you want to delete the entire thing, click off in the middle of nowhere, select it. All right, hit delete. All right. So we're going to talk about four main constraints. We're going to do coincident. We're going to do collinear, and if you're taking geometry, these may be familiar to you. Well, maybe we look at perpendicular, and my mind is escaping me. Well, parallel and perpendicular, I mean, they're kind of opposite one another, so I'll just do one of those. Yesterday we looked at the horizontal, so we're not going to do the vertical. We'll do tangent. All right, so if we'll switch back to Inventor, all right, and we can draw a line, and we can draw another line. So if we hit coincident, and once again, if you leave it up, it will pull up exactly what it's all about. But if I hit coincident and then click the two endpoints, it will make them coincident. They will be on top of one another. Now it's still not constrained. You can still move things around. Okay. You can still move it around. Now you are free to go ahead and say, all right, I can dimension this. I can put an angle dimension. I can say dimension from here to here, and that will set an angle, and we can say like 45. All right. Or once they're coincident and they're touching, we can say we can use perpendicular. So click perpendicular, click the two, and then now we have a 90-degree angle. All right, once again, you can still move it around. It's still not fully constrained. From there, so if I delete that, we can lay in two circles. All right, they can be different size or the same size. And we can lay in two lines. If you do this, it probably, if you want to follow along with me, don't make them vertical or horizontal. It just seems to work a little bit better. You don't have to worry about it accidentally getting locked on you, constrained on you. So you can hit the tangent. That's this button here, tangent. And you basically say click the line, click the circle. Click the line, click the circle. Or you can mix it up and hit the circle and the line, and circle and the line. All right. So if we go back to our slides here, we went over that. Then we're going to work on a very powerful tool called Trim and Extend. So if I switch back to Inventor, so Trim and Extend are right here. Here's Trim, here's Extend. All right, and let me adjust my geometry a little bit to make the Trim and Extend a little bit more intuitive. So we have this, and this isn't touching. These two are touching. They're going beyond. So if I do Extend and I mouse over, I'm not holding any buttons down. As soon as I touch that line, it extends it to the next thing it touches. If I click, it makes it permanent. So it extends, click, makes it permanent. Trim works very similarly. If whatever you mouse over, if you click, it will disappear. All right, so if it turns into a hidden line, if you click it, it will disappear. So we can make those go away. You can also make these go away if it turns into a hidden line. All right, and then you've come up with a slot here, so we have a slot. All right. The last thing that we want to talk about is the idea of combining the methods, which is, yesterday I may have given you the impression that you always want to like start with a solid and then we'll just add to it and add to it and add to it and add to it. The most efficient way is really to do whatever is necessary, both additive and subtractive, that gets the job done. You want to do it as quickly and as efficiently as possible. All right, so if we move over to 4.3, which is the part that you're going to work on in class, all right, you have 4 different items that we want you to model, or I want you to model. So one of the things that you guys can do when you open this up, go ahead in your system and click Open It in New Tab, and then you can, let me move this down so you can see it. All right, you can then, once you do that, see where it says 100% here, and it's zoom. And you can say I want to zoom 200%, and then that will allow you to see this up close so you can see what you need to draw. And it's also very handy if you want to switch between Inventor and this view. You can hit Alt and Tab, and it will tab between the last thing that you have been at, so you can switch between the two very quickly. All right, back and forth, and you can get your dimension and then go back and get your part. So if we look at this, you will see that we could model this in many different ways. All right, we could say we're going to do a great big block, and then from there cut out, cut out, cut out, and then add this. But that's like 4 or 5 extrudes. We don't need that many. All right, so probably the most efficient way to build this one is to trace this all the way around, make this form, extrude it, and then once that's extruded, make a sketch on this face, and then make a rectangle and extrude that. All right, same thing here. All right, it's probably most efficient. We could go in and make a box and then cut this out and then cut this out, but it's probably most efficient if we do the front view here and make this our sketch, extrude it back, and then go onto this face, make a sketch, and cut a hole all the way through. By the way, I'm missing an annotation here. This should run all the way through. This one here we can probably do in 3 different ones. All right. It's probably the best if we use this side view as our front view and have an L shape, and then we'll cut out this slot, cut out this slot, and that's probably the most efficient way to build that. And the last one we can do in one cut, one extrude, not a cut, one extrude. All right, make this sketch, make the little tiny square that is the center of your cam here, and then say extrude, and then it'll extrude it the whole way. So hopefully this helps you. If you can go on and complete 4.3 and do those 4. Don't forget your conclusion questions.